All right, everybody, this is your video over the four factors that affect a rate of a reaction. Okay, so you can see we have temperature, we have concentration, we have what we call the physical state of the reactants, or sometimes the surface area, and then the presence of a catalyst. Okay, so what we're going to do is there will be four smaller videos, each where we examine those four rates of reaction. Okay, so we're going to start with temperature and then move into concentration and then do surface area and then do a catalyst. And for each of those, minus catalyst, I have a demo that I have prepared for you. Okay, so remember, in a chemical reaction, it follows the rules that are laid out in collision theory, and that the reactants will not react unless all three of these pillars have been met. Okay, and first the reactants must collide. They must collide with the proper orientation and with the proper or the minimum amount of energy, which we call the activation energy if we were looking at it on one of our endothermic or exothermic graphs. Okay, and so those three things have to happen, and by adjusting some factors of a reaction, we can cause that reaction to speed up or slow down. Okay. All right, finally, we have a situation where we add a catalyst to a chemical reaction. Okay, so we're going to watch two videos here. One about how the catalyst causes a reaction to work, and then how a catalyst actually works. Okay, so let's watch a video here of a demonstration of a catalyst.
This is a short demonstration to show how a catalyst increases the rate of a chemical reaction but remains chemically unchanged.
Oops, I'm sorry, I'm trying to. There we go.
At the end. In the large beaker, I have a solution of potassium sodium tartrate at about 60 degrees Celsius, to which I'm going to add some hydrogen peroxide solution also at 60 degrees Celsius. The reaction between these solutions produces oxygen gas, so an effervescence will be seen when the reaction occurs. When I mix the two solutions together and stir, there is not much evidence of a reaction occurring at the moment. So I'm going to add the catalyst, which is cobalt chloride solution, which is pink. Please observe what happens when the catalyst is added to the solution. There is a change of colour and bubbles of oxygen gas and effervescence is beginning to be seen. The reaction is speeding up and the catalyst is clearly getting involved in the reaction because of the colour change. As the reaction subsides and less oxygen is released, the catalyst is returned to its original state and goes back to the pink solution of the cobalt chloride. So here the catalyst has increased the rate of the chemical reaction but remains chemically unchanged at the end.
Okay, so you heard a lot of information there, right? So a catalyst is just another compound that we add to a reaction to speed it up. Okay, so a catalyst speeds up reaction. When we talk about biochemistry later on in the semester, we'll talk about enzymes, which function as catalysts inside your body, and those just speed up those biological processes for you. Okay, so the catalyst here goes in, and the catalyst is not involved in the reaction as either a reactant or a product. The catalyst is just there as a vehicle to force that reaction forward, and then the catalyst actually can be retrieved at the end, right? So the catalyst will be unchanged from the beginning of the reaction to the end, because it doesn't really take part in it. It just provides an alternate energy pathway for that reaction to happen. Okay, so let's go ahead and move on to our next slide here. Whoops. Okay, so here's another small video to help explain how catalysts work.
In this video, you're going to learn what a catalyst is, how a catalyst works, and where catalysts are used in everyday life. Firstly, what is a catalyst? A catalyst is something which speeds up a chemical reaction, but at the end of the reaction has the same mass as it had at the beginning of the reaction. This means that it is not used up in the reaction. It must, however, take part in the reaction, or we might as well not have it there at all. So, how does a catalyst work? A catalyst works by providing an alternative pathway for the reaction to occur. This alternative pathway has a lower activation energy than the pathway without the catalyst. Here are the two pathways for a reaction. The blue pathway is the energy profile for the reaction without the catalyst, and the red pathway is the energy profile for the reaction with the catalyst. You can see here that with the catalyst, the activation energy...
Okay, so we can look at this here, right? That video is going to get more into like measuring activation energy. We don't really want to do that in this class. But you can see that how the catalyst works is it causes those collisions to happen, but in a lower energy manner, okay? So remember, back to our pillars of chemical reactions, they need to collide, and they need to collide with the proper orientation. That still needs to happen, but that proper or minimum amount of energy is lowered with the catalyst, and that's what causes the reaction to happen faster and speed up, okay? So what we're going to do here is we're going to use this information to help us fill out our final graphic organizer about catalysts and how they work, okay? Thanks for watching.